Okay, we're back. Here's a second video for section, not 6.1, but 8.1. And some cool stuff coming up here. We kind of did the hard part in the first video there, as far as using the law of sines to solve for um, one triangle or two triangles or an ambiguous case where you can't get anything. So now we're going to start trying to apply not only those formulas, but also a new formula here for area that uses a sine function as well to solve for triangles that are oblique or not right triangles all the time. So if you remember, and we're talking about triangles at this point, that the formula for the area of a triangle, 1/2 base times the height, yeah? But that always made sure that the kind of prerequisite to use that was that you had to have a right triangle to begin with, all right? So I'm going to get you a formula here that you can use on any formula, or excuse me, any triangle without, well, it'll work for right triangles too, but it has to be situated in a certain manner so that you can use it appropriately. So what we're going to say is that this angle here, this area is going to be 1/2 base times height again, or side A times side B, which we can call this side here and this side here, and the problem that's coming up. However, an included angle has to be between the two sides, right? So the included angle has to be here for part C. That's the only prereq for using a triangle that's not 90 degrees. So this formula now can get the area of just about any triangular shape. So if you look at this example, look at example 5, and it says Rochelle's house is on a corner lot, and you're being asked to find the area of her yard if the edges, her yard edges, measure 56 feet, 40 feet, with an included angle of 135. Now, I already called one side A and one side B, so I'll just kind of hold strong with that and stay consistent. But you can really call any side A and side B. The sides doesn't matter because when you use them in the formula, the order again, it's not going to have a different effect. You can do it in any order. So if I were going to use that formula, area is just 1/2. Pick a side, 56, times the other side, 40, times the sine of the included angle, and in this case, 135. Now, make sure your calculator is in degrees. And to save time on the video length here, I went ahead and did that ahead of time. So you should get, in degree mode, 791.959, excuse me, feet squared. Because if you're in feet, you got to be feet squared. Or approximately, you can say 792. Cool, yeah? So now we're going to start talking about some actual applications where we can use these triangles to help us out a little bit, especially using what's called the law of sines. Now, the law of sines, remember, requires that you know 3 out of the 4 things. In other words, you can have the sine, and you could call it any side, excuse me, any angle, as long as, and let me kind of put a big A in here to represent an angle, and the sine of angle B over side B. And the requirement again for using law of sines is that you're going to use the angle that's opposite the side you're talking about that you either have or you're trying to solve for. And the other suggestion I'd make is to always draw a picture. So in this case, take a look at example 6, and I'm going to encourage you to draw a picture. So you have 2 radar stations, and this is actually how they triangulate positions of aircrafts at times too. So this stuff's all true. And if you had a radar station over here, right, and a radar station over here, and they're, let's see, how far apart? 20 miles apart. It's pretty far, right? Notice my units are in miles. And you have some aircraft, oh, flying above. Let's put the airplane here. I don't know. Okay. And the angle of elevation with the first station, and here's the second station, is, oh, 35 degrees. And the second station is way over there at 15 degrees. Now, again, I drew a nice picture there for me, and they want to know what the altitude of the aircraft is. Now, the altitude is really the height off the ground. And because I've already kind of done this one, let me encourage you. Again, our goal is to figure out that height there in red. But before we do that, let's just look at the blue triangle there. Because to do that, you can assume that this is 90 degrees, but you need to know a couple other things. So to do that, let's see if we can figure out one of the other sides first. So in this case, let's figure out this side, and I'll call it B. Right? And what you can do, you can use the law of, excuse me, sines to figure out some things. But I know that this side here is 20 miles, but I don't know the angle. And really, the trick to finding the angles in the triangle is you know that they all have to add up to 180, right? So if you took 180 degrees and you subtracted 35 and you subtracted 15 degrees, you'll probably get, I think, that this angle here in gray should end up to be about, oh, what is that? 180 minus 50, so 130. So this should be 130 degrees. Now that's of the whole angle, okay? It doesn't do me good for any smaller triangles I'm trying to create later on. So let's go ahead and start cranking some stuff out. I know that the sine of 130 degrees is opposite, that angle there is opposite 20 miles. And I also know, if I'm trying to figure out, again, side B, that the sine of 35 degrees is going to be over side B. Now, if I both, and I'm going to do this one time here, and then I'm going to start doing it automatically. But if you multiply both sides by B, those go, and it remains on the left side. You okay with that? And then if I multiply both sides by 20, this 20 goes with this 20, and then I end up with B sine of 130 on the top times the sine of 35 times 20. To get B by itself, I then have to divide through by sine of 130. So I'm doing three algebraic processes, all in this one line here. But what you're going to see me do in the future, I'm going to do it in my head. So if you wanted to solve for this thing, B is going to equal, notice these two go now as well. And on the right side, you're going to have sine of 35 degrees, all times 20. And I sometimes put it in the front here. And you know what? Let's go ahead and do that because let's establish the habit now. So we'll put the 20 here, sine of 35 degrees, all over sine of 135. No, not 135. Now, I highly recommend listening to this next suggestion. On your calculator, I would type in 20 times sine of 35 and hit enter, and it'll give you the answer just for that top part. And then when you divide by the sine of 130, and maybe I'll just show you, it's going to take a second. I'm going to shoot myself in the foot here for trying to show you something live on talking on the phone here. Let me go ahead and, as I'm stalling here to boot up my calculator, um, see if you guys can see what I'm talking about. So again, let me write that down on a side piece of paper here where I have, let's see, so I don't have to keep toggling back and forth, sine of 35 degrees, 20 sine of 35 degrees over sine of 130. Okay, now let me guess ahead of time here as my computer's loading up that answer, if you do it on your calculator the right way, should end up with 14.975. But just as an exercise, just to make sure you can do it, let me make sure I'm sharing this calculator screen. Okay, let's do that. And so here's what I'm trying to recommend to you. If I were you, I would hit 20 times, and you got to check your mode first too. Make sure you're in degree mode. So I am in degree mode. So I'm going to quit out of that. So 20 times the sine of, what did we say, 35 degrees? And before I do anything else, I always just hit enter. That way I can't, the computer can't divide before it's supposed to. Sometimes you get the same answer, but then I would hit divide, and you see how it takes the answer and just puts it in there on itself? So again, All I did is I hit the divide button and it put the answer there ahead of it. So divided by sine of, oh, I think it was 130, right? Check my notes here. And if you do that, there's your 14.97. So I highly suggest you chop that up when you can, and it'll make life easier on you as you go forward. Okay? Well, you should be standing there or listening or watching, whatever you're doing, saying, this is not what I was looking for. I'm looking for that red height H, in other words, the altitude of the aircraft. So why the heck did we go ahead and figure out that B was 14? I didn't want to put that in red. 14.9 or 14.975, however you want to put it. 14.975. And the reason we did that is because now I've created another triangle in red here with this side and this side and this side. And because I know that this is 90 degrees, check it out. You can use the law of sines again and say the sine of 90 degrees over the side that you just found. And you could have done this and found the other side this way too. And that's going to equal the sine of 15 degrees. And notice I'm choosing that because I want to figure out what that red side H is opposite the sine or 15 degrees, opposite this angle in here. You get it? So even in the next example, sometimes you can use the law of sines with the law of sines with the law of sines, or something even called the law of cosine. And that's coming up. Now watch the magic here. Remember in the last example that the B down here is what I wanted to solve for. It ended coming up. This 20 ended up going over here, and the sine of 130 ended up coming down there. Get good at this so you can see if I multiply both sides by h, I'm just going to have that thing solved for. And what happens is the 14.975 comes up top on the other side. So I'm going to multiply both sides by that factor. But I've just done it for so long, you can see it happening in your head. So I would write it all out like I did here until you can see it in your head. Sine of 15 degrees all over the sine of 90. Now, right off the bat, you should be able to tell me the sine of 90 is 1. So you can just completely disregard the bottom. And my h, as I'm writing things out here, if I'm looking at my notes again, just to save time, it should be 3.874 miles high, depending on how much you're rounding this number. If you rounded it to 14.98, you might be just a hint off. But here's where your rounding comes into play too. So now we figured out, and this is how they do it for real, how high that airplane is off the ground. And really, if you know you have some kind of transponder or transmitter, these radio stations, they can figure out how high that aircraft is, including the aircraft's autopilot at any time. So it's very, very helpful, especially in foggy and dark weather, that computer is working. When I got to this portion of the class, I started seeing this stuff using, and again, we're using some light examples. They're not all that detailed quite yet, but really cool stuff. Okay, so let's do one more, and then we'll call it good for this section. And again, I'm going to highlight or ask you to draw a picture. But I don't know if you've ever been out to Coit Tower in San Francisco. I think they made that for the firefighters. It looks like a big nozzle, and I think it's something like this. I don't know. I'm not going to make you suffer through my picture. But it comes down on the ground, and if you read it, Coit Towers, they want to estimate the height of that thing. So this whole thing is some height from top to bottom. Okay, so bear with my drawing. And this person stood on the street and measured the angle elevation to the top up here to be 39 degrees. Okay? Don't know how far away they are from the tower. Then this person moved closer, and this is what these estimators do as well. They moved closer, this person, and measured the angle of elevation to be 50 degrees. But they moved 83 feet closer, so you know that this is 83 feet. Now, based on that, they're going to say, figure out the height of that tower. Notice I'm putting some angles in there. Now, what is this angle? I'm just curious. You guys ever know what a supplementary angle is from geometry? where the two angles of a straight line have to equal 180? And if that's the case, then this angle here has to be 130. I don't know if you can read my writing there. Let's try one more time. So that's 130. And again, if I were to do the fact that if I wanted to figure out what this angle was, all the angles in this first little triangle here, and I'm looking in here, all of these angles have to add up to 180 themselves. So if you go down here and 180 minus 130 minus 39, God, what is that, 169? So this angle here has to be 11 degrees. And you can do this. Notice I'm just kind of cranking out stuff based on just my knowledge of geometry. And this has to be 90 if it's, unless it's the Leaning Tower of Pisa. And if that's 90, this is 50, that's 140. That's going to force this to be another 40, huh? So I didn't have much, just an elevation to start with and an elevation after this person walked closer. But I now have a bunch of angles to kind of tinker around with. Just like the previous example, let's find out a different side here. Let's call it side C first so that, and notice I'm going to do it with this first triangle that I highlighted in black here so that I have something else to work with when I want to solve eventually for that red height here. Eventually I want to get to that. But to do that, I need a little bit more information. So here we go again. It's the same problem over and over. The sine of 39 degrees over side C that I don't know is going to equal, notice, I can take the sine of 11 degrees. I always have to have an angle on the side that I do know, over 83. Now here's my cross multiplying again. Multiply both sides by 83. 83 sine of 39 degrees. Multiply both sides by C. Your C is going to come up here. And then I'm going to divide both sides by sine of 11. So you see how that works? This ends up going down there. That C comes up here. The 83 goes up here. And I'm doing all that. And once you're comfortable with that, you're going to be able to fly. Because watch how fast. All it is now is an exercise on your calculator. And if you crank all that out, I think you get 273.74 feet. Remember, the giveaway is this was in feet. All right, so that's my side C. That's this. Now what we're going to do, and what I'd highly suggest, is kind of doing it all over again. But this time you're going to try to solve for side H. So here we go. The sine of what angle's across from H, and I'm going to look at this triangle. Now we'll call it the green triangle. This triangle. And what you can do is you can say, oh, the sine of 50 degrees over H is going to equal, now check this out, I know that angle's 90 because it's supposed to stand straight up. I hope it's 90. Over my side C, which was from up here, huh? So 273.74. Now again, as I scroll down here, cross multiplying everything, you're going to get 273.74 times the sine of 50. Don't forget that. All over sine of 90 side, and you're done. Again, I don't have to type in sine of 90. I know that's just one. So on the top, if you just type in 273.74 and you're trying to solve for h and times that number times the sine of 50, you should come out with, I think 209.703 feet. Okay, and that's it. So all these examples now, all these examples now will kind of depend on what you're handed. So you're not going to know what you have unless you draw yourself a picture. In all of these examples, we were able to use the law of sines mainly because you knew what? An angle, an angle, and a side. You knew 3 out of the 4. In the previous video, we talked about how to find the angle, but this, when you're looking at distances, is pretty straightforward, and there's no really mystery to it. You just got to figure out the geometry like we did for first triangle here, And then again in green, we did the second triangle after the fact because we then knew this side C. So it might be a two-part problem, but don't stress. It didn't only took maybe 3, 4 lines of work here. We did one problem with 3 lines and another problem with 2 lines. Okay? So go ahead and keep practicing the examples again after this, the lecture questions. And if you have questions, get a hold of me or talk to someone in Math Lab. Great job.